Welcome everyone. Today we would be going across one of the projects in Project Pro, which would help you understand how the projects in Project Pro work, how you can use them to, enhance your experience in practical experience, especially in the big data world. So let me start. So this is the home page of Project Pro, and here we would start with the batch processing with PySpark project. So these are the different videos that are there, which guides you through the complete project. But here in this particular thing, I would be directly showing the demo. So firstly, we'll go to the project details page and we would understand what is the use case that we are trying to solve. So firstly, as the name of the project states, it's a batch processing job that we would be creating and we would be running the same. Now, what does batch processing do? So you have data coming in, let's say, in batches, or you have data which is getting accumulated over a period of time, and you want to process this data. And the processing of the data need not be as soon as the data arrives. If you want to process the data as soon as the data arrives, it goes into real-time streaming. Now, in our real-time stream processing, and the data coming in is called as the real-time streams. Now, in this particular case, we would do batch processing. For example, here I will be taking an example of a Wikipedia data. So this is a data about who logged into Wikipedia, which pages they, whatever actions they did on the page, they edited a page, or they did something with it. And that is a one-day data. So there are a lot of scenarios in the big data world where you have data accumulated for an hour or for a day, and then you process it, and then the result that you get out of this churning of the data or processing of the data is something that you use for either analytics or for training machine learning models, or for just visualization to get a graphic view of what has happened over a day, like over a month, over a day, and so on, so that you can figure out the trend. So here, what we would do is build this particular architecture or a data pipeline. We would first have raw data coming into S3. So we would just upload a file for this particular use case. Now we would be running Spark job for processing this raw data. Now here, EMR is one of the AWS service which provides Spark cluster. It provides different processing clusters. It provides Hadoop, Hive, Spark, Flink, whatever you choose. We would be using the Spark cluster from the EMR. And once this cluster is up, we would be putting a batch processing job onto this cluster. This job would be doing some processing on the raw data, and whatever is the final output, it would be putting it back into another folder within the S3. Now, this processed data, we would be querying this data using AWS Athena. So this forms one of the pipelines wherein you have the raw data, you process it, you get the processed data, and then you are able to query that processed data. So once you have the access to this project, you could go via this project detail description in detail and try to understand what is it, how things are getting connected, and relate it to the demo that I'm going to show. So let us begin. So here, firstly, we would go to EC2. This is the AWS console, and I would go to the EC2 service. And here, I would go into key pair. If you already have a PEM file, then you are good. If you don't have, you can create one. Now, what we would do is say create key pair, and I would just have a name to it. So EMR demo as Mantri. So I have selected RSA and .pem, and I will just say create key pair. As soon as you do that, it will be downloading the PEM file. So I would say, okay, I would like to download this. So the key pair is there. Now we would go into EMR service. This is where we would launch a Spark cluster using EMR. I have this one cluster already created, but just to give a just to tell you how you create a EMR cluster, I would just come here. So there are quick options wherein you can select this Spark option. It has Spark, Hadoop, Yarn, and Zeppelin. And you can just choose the key pair that we just now created. And that's it. You would be you can name the cluster here, whatever you want to name, and you can say create cluster. For my case, I would go to advanced options because I want to select a particular VPC. So I am not fine with the default VPC. It's private VPC that I have. So this you have to select this Spark. Ensure that you select Spark 2. Either 3 or 2.4. It's not compatible with Spark 3 or whatever code I have already written. There might be some changes required. So here I would select Spark 2.4.8 and Zeppelin. If you want to select, you can select. Basically, we are more interested in having this Hadoop and Spark. Now, what we would do is rest of the things is fine. Next, and here I would like to select a different VPC. That is the whole reason I am coming here. Master, 1 node is fine. Core, 2 nodes is fine. Both are on demand. This is a very small cluster. And this will auto terminate in an hour of inactivity. So that I'm fine with it. Cluster, let me name it as demo cluster. This is created by me, so I'll just name Mantri over there. And next, here you have this EC2 key pair, which we had even there. So EMR demo Mantri. And that is about it. We are fine with the default EMR role and the EMR EC2 role. And we will create the cluster. Now, in the meanwhile, while this cluster is getting created, it takes around somewhere between 5 to 10 minutes for the cluster to get created. So in the meanwhile, what we can do is go to S3. Now here we would create a bucket within which we will create 2 folders, one for the input data and one where the output would get generated. So let us do that. Let us create bucket. And let me create the bucket name as EMR demo S13 1. I think that should do it. I'm choosing US West 2. I hope my EMR cluster was also in the same region. Yeah, this was US West 2 itself. And then you have the default settings. I'm not changing them. So I'll create this bucket. Now I created the EMR demo S131 bucket. So let me go inside and I'll create 2 folders. One folder would be the source folder or the input folder. I'll create this folder, and yet another folder would be data output, where we would be having the generated or processed data. Now within the source folder, we will put in our raw data. Now I have this raw data with me. Just to give an example, let me open it with Sublime Text, how this data looks. So this is a JSON data having a few of the records, like how many records? It has like whole lot of records. If you see, it's a very, very big file. And this is like 1 day's data, which is 2015-09-12. And it has the complete data for the day. Now it has the comments which were given by the different users, which channel they have given comments on, whether it was English Wikipedia or Japan Wikipedia and so on, Spain Wikipedia, Korean Wikipedia. So these are the different channels, and then which city name, if at all there is, and there is whole lot of data. Each line over here is one JSON record, And there are a lot of JSON records like this. If you want, I can just go to the bottom, and if we see there are 39,244 records. Okay, I'll close this file and we would go back. Now we would go back here. I would upload this. Now this file is present over here. I can just drag and drop and I would say upload. Now this file is getting uploaded. Okay, this file is uploaded. So now our raw data is ready in S3. Now coming back to EMR, we would just wait for this cluster to get created. So when the cluster gets created, this would go into waiting status. That means the cluster is ready and it's waiting for someone to submit the job. Now here, as you can see, we have the master public DNS. So this is the master node of the Spark cluster. Now what we would do is, in the meanwhile, we would open up the SSH port for this particular instance. For that, I'll just come to another window, EC2. I'll just open it in a different tab. I think I have this Zoom related stuff coming up. 1 second. Okay, so now coming to this EC2, I'll just paste this. This is the master node that we were having. As we are going to SSH into this master node, what I would do is I will go to the security group. That is here in details security. I'll go to security group and I would edit the inbound rules. Herein, I want to ensure that the SSH port is opened up for everyone. If you know your local machine's IP address, you can just open up it for your local machine. For now, I'll just open it up for all the IPv4 addresses. I'll save the rules. Okay, it already exists is what it says. So that should be good. Does it exist? Yeah, it existed. Sometimes it doesn't exist, and that is how you will not be able to log in into this particular master. So just ensure that it exists. So now, given that is done, we'll come back to the EMR. Let's see if it is up. So here it says its master is bootstrapping, core is provisioning. So it takes little time. As you saw, we did it like 5 minutes back. And it's still setting up the cluster. So let's see, let us refresh. It's still provisioning, but I think in the meanwhile, I should be able to SSH. So let us do that. So firstly, my PEM file should be here, and I should change its permission to a restricted permission 400 of, let me figure out the key pair name. So what was the key pair that we created? So the key pair was EMR demo S Mantri. So let us go back. EMR demo S Mantri.pem. I'm just restricting the permission to 400. And now we would SSH into the master node, which is this particular node. And the command to do that would be SSH-I PEM file Hadoop @ the machine name. So this would also come here. If you go into the EMR and if you say connect to master node using SSH, it gives you this instructions. How do you SSH? And I'm using exactly the same one. So here, as you can see, I'm able to SSH into the master node. Now, what we would do is, let's see the code. That is the Spark batch job that we are going to run. We are going to run 2 codes. One code is for filtering and another code is for aggregation. Now, what is filtering? When you have lots of records and you want to filter those records based on a certain condition, that is, if the condition matches, then only that record is valid to be present in the output. If the condition doesn't match, then just drop that record. That is what is called as filtering. So here what I'm doing is, so I have some bucket which I had used earlier. So let me change this bucket name to the one which we are going to use, which is Mantri EMR demo Mantri 1. So let me just copy this. And I would change this to EMR demo Mantri 1. And then within source folder, we have this particular JSON file, which we have just now uploaded. And then output, we want to write in the same bucket in data output folder. And I have also mentioned another folder within data output called as filtered, where our results would go. Now, let us walk through the code as to what is happening over here. So if you see first line, these are just input declarations or like variable assignments. I have S3 data input path as the JSON file and S3 data output path filtered as the folder where my results should go in. Now, I'm defining everything in the main method and I'm calling this main. So this is the function which, this is something which would get run as soon as you have launched or when you are using this main.py file, and this would call the main function. First line, we are creating the Spark session. So you create it using Spark session.builder.app name. You can give any app name that you want and you say get or create, and this creates a Spark session. Now we are telling Spark to read a file. This file is a JSON file. If had it been CSV, we would have given CSV. And there are some formats which are supported by Spark, and you can give all those supported formats over here. If you read the Spark documentation, you would have these details. And because it's a JSON file, I have given JSON, and then we have given the input path. Now this got read as a data frame. DF is nothing but it stands for a data frame. It's a variable over here. You could give any variable name. And then I'm just using df.count, and this would give me the total number of records. As you saw, there are 39,244 records, and that is what should come over here, and this should get printed. Then we are doing filtering. This is data frame.filter. This runs on any data frame variable. You can have filter, and then you say two things to filter upon. One is if is robot is false and country name is United States. So we are figuring out how many humans in United States did any of the actions on the Wikipedia page or did any comments on the Wikipedia pages. And then this number should be reduced because a lot of the data is robotic data. Some of them is actually done by humans, some is done by robots over there, and the data comes across different countries. So with this two filterings, I should have a reduced data set, and that I would print out how much data I have received. And then I would just showcase 10 rows here. I would print the schema, and then I would write it. So here, this is the filtered data frame dot write dot mode. If anything is present, it would be overwritten, and I would write it in Parquet format and in this particular output path. And then I would just print that the filtered output is uploaded successfully. So this is the code that we are going to run. So let's copy this code. Let us go into our master node. My session is gone, so let me just create a new tab. And in that new tab, just let me log in again. Okay, and let me copy this code again, and I would create a file main.py. You can name the file anything, that should be fine. I have copied the content. I will save this file. And now I would just run it using Spark submit. Before running this, let us check if the EMR cluster is up. So let us go to EMR. Let us see, it should be in waiting state, and I think it has reached that state. It is waiting. That is, it is ready, and it is waiting for this job to get submitted. So let us go here and say submit. So now this is the Spark cluster doing its job. So we will just give it a minute. It's just 39,244 rows to be processed, which is a very small number. And I think it's just done. So we have received this out thing, and it has completed. We have got this final result. The filtered output is uploaded successfully. Now, let us see if we have got the other print statements. One of the print statement was total number of records in the data set. So here it is. We had 39,244 records, which are the total number of records. And let us see the total number of records in the filtered data set. It is 528. So there are only 528 records which satisfies both the filtering conditions. One is that is robot is false and country is United States. Now, this is what is called as filtering. This is how the record looks. If you see, country name would all be United States because we did the filtering on it. And second was is robot, which would be all false. Okay, so now, and this is the schema. Now I have printed the schema for a specific reason, which I'll come to later, but this is the schema of this particular data set. Now let us do aggregation. What is aggregation? Aggregation is where you are combining the records based on certain condition. Now here, what I have done is I have grouped by channels. I want to figure out for a particular channel how many records exist. That means if you see the, let me just show you 1 second. If you see this particular data set, we have channel here as an attribute, and its value is the different Wikipedia countries or I mean, this is just called as channel, but the way it is done is using different countries, that specific Wikipedia, whatever they have named it as channel. So there is en.wikipedia, there is Japan.wikipedia, Korean, Spanish, and so on. So there are many of them. Now what I'm doing is I'm grouping by channels and I'm figuring out how many records exist for a particular channel. Now, how do you do that? And that is called as aggregation. So how do you do that? We have this Spark session. Again, we are opening up the Spark session using Spark session.builder.app name. Then we are having the data frame, which gets created by reading this particular input file. We again print out the total number of records in the input data set. And then we group by the channel. And for each channel, we find the number of count. So there would be two things in this particular data set. One would be the channel and second would be the count for that channel. And we would figure out the total number of records in this aggregated data set. We would show 10 records. We would print the schema and we would just write this final data frame into the output path. So here, let me just quickly change this particular bucket. And for that, I'll copy this. We would go to S3 and copy the bucket name, and we would change it over here. So we have this, and we have this over here. And that is it. So this is the aggregation. So I'll just copy this, and we would create another file. So let me just clear it. Okay. And we would have aggregation dot file. Okay. And this I'm writing in the aggregated folder. I'm saving this file, and let us do Spark submit. Okay. So it's about to complete and it has completed successfully. Now, if you see the last line over here is the aggregated data has been uploaded successfully. We would just check what it has done. So it has such kind of output, channel and count. And for the different channel, how many records were there. So with these two jobs completed successfully, we should now have the output present in the output folder. So let us go and check that. So here in the S3 bucket, let us go into this bucket and into this data output. So we have two folders as expected. One is the filtered, where we have this Parquet files, which are now containing the filtered data set. So all the records here would be for which is robot equals false and country is United States. And then in the aggregated one, we have this different Parquet files, and each of these files together would contain the data of the different channels and their count. Now, how would you query this data? This is present in S3. So if you come to Project Pro, so we have now done step 1, 2, and 3. We have the process data in S3, and now when we are querying it, we should be querying it using Athena. So let us see how do we do that. So for that, we would go to Athena. Here, if you are coming to Athena for the first time, what you would have to do is you would get some page like this, and you would say launch query editor. You would get this page, and here in the settings, ensure that you have some result location. So I just used one of the S3 buckets for my result storage. And then I come to editor, and here I will use AWS data catalog and database. You can create a database, or you can just use the default one. For now, I would just use the default one. And I'll also tell you how you can create your own database. So here in tables and views, I would do create, and I would say create a table from data source. So I would choose this. Let me name this as filtered Wikipedia data. So filtered Wikipedia, let's say, or Wikipedia filtered. That would be a better name. And then description is optional. You can put some description. Filtered data from Wikipedia. Then if you want to create a database, you can click on this, and then you can have your own database name. If you want to choose an existing one, just have this clicked, and you can choose some of the existing databases. For now, I'll choose the default. Now, location of input data set. For this, let us now choose the filtered data set. So we had EMR demo S Mantri 1. Within this bucket, we had this data output. And from here, we would be choosing the filtered. This contains all our output. So the different Parquet files are present over here. I would say choose. And data format, table type is Apache Hive. File format is Apache Parquet. As you know, we have written the files in Parquet format. So this is correct. You have different other file formats as well. So you have ORC, Avro, JSON, CSV, TSV. But for this, the selection is correct. Now, here you have the column details, wherein you have to write all the column names and the column types. That is where the print schema comes in handy. I have printed the schema, and that from there you can get all the column names and the data types. Just to keep it handy, I have already curated a list of all the column names and their data types. So I would go back over here, and I would say bulk add columns. As it says, it's anyways expecting all the different columns in this form, column name and their data types, and comma separated. So this is it. This is where you can have that print schema thing very, very handy. I would add all of it. So here are the different columns. And these are table properties, optional, optional, optional. And this is what it does. It's creating an external table called Wikipedia filtered with all these columns. And if you look closely, it says that the location from where this data would be picked up is S3, that particular bucket, data output filtered. And that is what does the job for us. I would go ahead and say create table. So it ran this particular query and it is saying that this thing is created. If you see closely, we have all these columns coming up. Now it becomes very easy to query this data. I would just do select star from Wikipedia filtered and let us run this. So here are the different rows from our data set. So now you get a paginated output. The first page contains 100 rows. So if you see, the first one is the number of rows, 100, and the next one would go on to the next pages. So you have all these different pages over here, and it has created this output. You can also put limit over here so that only those many records come out. Let's say limit 25 and run. And if you see, you got only 25 records. Now, if you see, for all of these records, the country name is United States because that was our filtering condition, and is robot is false. If I do something like, you can do this condition where country name is not United States and you would get 0 results. Okay, so that's about it. And now let us do a similar exercise of creating another table for aggregated data set. So let us do that. Wikipedia aggregated, and I'll choose the same database. Now here, my bucket is EMR demo S Mantri 1, data output, and aggregated. I'll choose this. Now it requires column name. So this time, as there are only 2 columns, I'll come over here. I'll use this channel and it's of type string. And then one more column that is count of type long. So as you see, there won't be any long over here. In that case, you could just use big int. And that's the 2 columns that we want. And this is the query that it created, which is good. We will create the table. And it ran. It now has this Wikipedia aggregated. Let us do a quick query. Select start from Wikipedia aggregated. This should be very less number of columns because this is an aggregated data. So if you see, the total number of columns are just 51. And it shows for every type of channel, how many record counts it found. Okay, so now our complete project is ready. We started with a file containing 39,244 records. We uploaded it into S3, so now it's available for processing. We created the EMR cluster. We ran 2 types of jobs, a filtering job and an aggregation job. You could do a lot of things in one job itself, but just to make a good sense out of what you are doing, I created 2 different jobs. And we ran both the jobs. We got the final output. That output got stored into S3. And in order to query the data present in S3, we created a table in Athena, and then we queried using that table. Yeah, I think that was all from my side. I'll open it up for questions.
We have a question on chat, Shruti.
Okay.
Anyone else who would like to ask any relevant questions, please feel free to ping on the chat and Shruti will take them one by one.
Sure. Okay. So the first question I have is from Rahul. How can we schedule this so that data pipeline runs every day and picks up new records all the time? So in big data world, we have tools called as orchestration tools. Now, this data orchestration tools, there are a few of them. The famous one is the Apache Airflow. Then there are others like Azkaban and Uzi, Luigi. But Airflow is like one of the trending ones at the moment. Using Apache Airflow, you can orchestrate the jobs. What it does is, what that means is you can schedule it at regular intervals. That could be minute wise, that could be hourly, that could be daily, very, very similar to what cron tab does, but it has much more features. You can have the complete graph as to what task should trigger after, if that task is successful, which other task should get triggered, and so on. And you have a very good mechanism of intimating you if anything fails, if any of the task fails, if the pipeline fails. And that is what is one of the tools which people are widely using for data orchestration. Just to give a just to tell about it, so airflow.apache.org is the website. And yeah, this is the one which is the data orchestration tool. It's, you can programmatically author, schedule, and monitor workflows. Please,
So
can you
raising his hand, I think he has a question.
Sure, go ahead.
Soham, would you like to ask?
Yeah, I hope I'm audible.
Yes, you're audible.
Yeah, madam, you chose here Amazon Athena for querying purpose, right? I wanted to ask that, can you just differentiate me that for what purposes Amazon Athena is being used and how different it is from AWS Redshift? Because
Uh,
a lot of the times I have used AWS Redshift, but I was not able to differentiate between how Athena is different or how it is. Is it more efficient or is Redshift more efficient? Oh yeah.
okay. So basically,
I,
we
and yeah,
have
I'm sorry to interrupt. Yeah,
hmm,
and had to ask one more thing, that how partition works in PySpark. That how should we work on it that it will increase the optimization of our Spark jobs? Can you just elaborate on that particular topic also?
okay, sure. So let us start with the first question as to when to use Redshift versus when to use Athena. So if you have data in S3 and you don't want to put it into your data warehouse, because Redshift is a data warehouse. If you want to put your data into data warehouse, you have to ensure that the data is structured. Structured in the sense you have proper columns defined with their data types. Now, in this particular case, when I'm creating the table, I could create a string which now contains a JSON data. So it could be an unstructured data as well, because S3 is, if you select this, you have, if you see, you have array and map as well. So it supports unstructured data. You can just have data directly present in S3 and you can query it from Athena. Now, if you want to use Redshift editor, you have to actually put the data into Redshift. Now, Redshift is a data warehouse. It has its own cost. And if it is something where, you have like the data in the middle stage where it is not completely processed and put into Redshift, this Athena serves as a very good tool for querying that data. Most of the cases, what you would do is do all this filter. So you have this one job which is doing some filtering, then you would have another job which is doing yet some processing, and then the final data goes put into the Redshift. And then that final data can be queried using Redshift editor. Now, why do we have this middle stages? Because let's say whatever filtered data that I have at the moment, for example, is robot is false and country is United States. There might be different usage of this. One might be using it for recommendation. Another job might be using it for, let's say, ML model training. So there would be different processing that would be done on the same data. Now, if I want to do that, both the time I'm doing the same filtering. So what I do is I segregate it as one job, which would give me half-baked data. And then I process it further to get to come out with a fully processed data. And that fully processed data, you can send it to Redshift. And that is where you can use Redshift editor. But for some data which is present in S3, you will have to query it using Athena. You cannot query data present in S3 in most of the other tools. Does that answer your question?
Yes, ma'am. Yes, I got it.
Okay. Then let's come to the next question, where you were asking about partitioning of the data sets and the optimized way of doing it. So there are a couple of things that come into picture. One is the column based on which you are partitioning. And that would be something which is mostly chosen as a timestamp related field, because that makes things pretty much easy. So now here, as you see, I have a data which is for one particular day, which was the Wikiticker data for this 2015-09-12. Now, one option is I partition it by day, or I partition it by month, or I partition it by smaller granularities like R. Now, how do you partition it? How do you decide which is the best partitioning key? I could have also partitioned it using channel. So you decided by your query pattern, how you're going to query it. Let's say I'm going to query only data from certain range. Let's say if I'm doing recommendations, I don't care what people did 6 months back. I only care what people did in last few months, like let's say last 3 months. So that means I would be querying using timestamp. And hence, most of the queries that I have seen, it makes much more sense to do the partitioning from timestamp perspective, because people are more interested in getting data from a certain timestamp. And that is where you will see the most common partitioning patterns are like hourly partitioned, monthly partitioned, daily partitioned, and so on. So that is how you decide the partitioning. In order to decide it, you will have to first see the query pattern. Let's say most of my queries are based on channel, then I could even have partitioning based on channel. But then it leads to uneven partitioning. Maybe one channel is heavily used and that would become a very big partition. Another channel is hardly used and that would become a very small partition. And you don't want to get into that state. That is why you mostly end up choosing time partitions. So yeah, choosing the appropriate partition makes a lot of difference in the big data world. And the main driving force behind choosing which column becomes the partitioning column is based on the queries that you run.
Okay, ma'am.
Yeah. So
there
was
a question on chat also, Shruti.
Okay. There was one question by Benjamin. Please, can you recap what was done? Because he joined a little late. So
we can send the recorded version if you don't have time. I mean, you can take in questions. If we have time, we can do it.
Okay, sure. Let me go to the next question then. If time permits, I'll come back.
Yeah.
Is there any possibility of mistakenly overwriting your output files if you have a scheduled job? Yes, of course, there is definitely a possibility. And you should be very careful while using overwriting in production scenarios. Most of the places, what you do is have something like appending. But if there is you can use appending or overwriting based on what you need, but overwriting is generally helpful when you have, backfills, you have a half-baked job, some partitions got written, some did not get written. There are scenarios when, cluster might go down or anything, any mishap can happen. That is where overwriting is generally helpful, but it could be problematic as well if you wrongly do stuff. So yes, your question is correct. Like there is definitely a possibility of mistakenly overwriting the output files in a scheduled job. But generally what happens is when you are reading the data, right? I will tell you a production scenario is what generally happens. So when you are reading the data, your data doesn't look like this. Your data looks something like this. Wikiticker hyphen the year, hyphen the month, hyphen the hour. And then this has the different JSON file or one JSON file. Now, what happens is when you are writing the output, You take all these YYYYMMDD model, even HH if it is hourly partitioned, and you format this output path using the same pattern. So you have here also, you would have something like 2015, 09, 12, and so on. So the entire partition doesn't get overwritten. I am overriding only this particular thing for this particular input. And while this is like one thing, so the actual thing in the job which runs regularly is YYYY, MM, DD, and so on. And this gets replaced based on the timestamp at which it is running. So let's say I want to run this on a daily basis. Then I would say something like my execution time, that is when this job is getting run, or when this particular, when this particular job is getting run, minus, let's say, day one. So I'm running it for yesterday's data, and using this particular timestamp, I would derive all of this YYYYMMDD, and only that particular folder is getting affected on every run. That is what happens in production, and hence your entire data doesn't get affected, only that particular partition gets affected. So I hope that answers your question, Jose. And then I would come to next question. How do we handle incremental data coming in S3 in regular intervals, say coming every 2 hours in aggregated format? Do we need to write conditions in code to take the new data? Now, this is a interesting question. Depends a lot of times on how you are thinking around it. So generally filterings and transformations are very, very common when you have this 2 hours data getting processed. Aggregation is rarely a thing, but I'll just tell you how it is done. Let's say you have some data where you are writing the final output every time. Now, what happens in that particular, let's say you have this table itself, let's say a Redshift table where you are writing it, or let's say even an S3 data set for that matter, S3 folder where you're writing this data. What you would do is you would take this data, whatever is present in your last generated output. Now you would take the already calculated output until now. And then what you need to do is just add this processed data from 2 hours. Now, how this is playing the role. So let's say in this particular scenario itself, you had such kind of data coming out. Now let me take this 4-5 rows. And you had this data. And then when you process, so this is coming from your first data set. And when you do the processing of this second data set from the 2 hours, you would have small numbers. Let's say the process data set results into some numbers like 3, 10, 12, 30, and so on. And let's say 9. And then you have to do nothing but aggregate this together. So you have to add 33 and 3, 219 and 10, and so on. It's nothing but a join that is happening, and you're adding up these two numbers. And then you're overwriting the same stuff which is present in this table or the S3 folder. And that is how you keep on continuously incrementing your counts. Now, if you want averages, you would have to keep the number of counts as well as the number of sum of whatever you're averaging on. So that is how you could get averages as well. So yeah, that is how it works.
I have a question on this, Shruti.
Yeah.
Sorry to,
Go ahead.
I have asked this question. So in this case, do we need to like have a persistent storage to keep the historical data as well, right?
Yeah,
Because
generally,
we don't.
right.
So in this case, if we are not having the historical data, not be able to like do these sums or whatever counts are there, right?
Right. Right. Now this, both of them are a persistent storage itself. S3 is in itself a persistent storage, and your Redshift table, if you're putting it in Redshift, that also is a persistent storage.
And how do we do it in how do we read this? This is about output. Do we need to encapsulate some logic in the code? Like in this one, there was a single file, right? We read that single file. Now in
Hmm.
that same bucket, if we have 2 3 files,
Yeah,
our code will read all those files at once. But we
yeah,
need to have a logic which separates these 3 files, right? So do we need to write this in the code?
not necessarily. For example, here S3 data input path is one. Yes, you'll have to write it in the code. And another would be, let's say, your S3 data input path two, which is your aggregated data. And then you would have, this is data frame one, you would have another data frame two. And then you are joining data frame one and data frame two. Data frame two, you would do this processing of the aggregation, and then you would be joining this aggregated df2 and df1. Like let's say this is df1 and let's say this is df2.
Okay.
Okay, and you would be joining df1 and df2 to get the final data frame, which you would be overwriting on the same location.
But every time this S3 path will keep on changing next time, because we need
No,
to
in
in
that
the
particular
runtime.
case, you won't go via this logic. That time it would be like a fixed one, something like the filtered one. Your
Okay.
aggregated things won't change when you have to, you have this kind of logic. Your final output would go into one place only. Only your input would be differing every time.
Yeah, correct.
Correct. Okay. And then we have, do we have an entire flow of project with integrated IDE, which have property files, SQL files, .sh file, and of course, Python or Scala files that we are running on AWS cluster, kind of how we saw manually writing file and running with Spark submit. But only thing is we would deploy through Bitbucket or GitHub. That's correct. So generally, if you see all the production kind of scenarios, what we do is we have a proper IDE wherein you have let's say I would have some folder which is meant for this Wikipedia data, and where I would have filter.py, aggregation.py, and so on as the files, and I would be uploading it to GitHub. And then, while I have a job, like Spark job, which is scheduled, I might not even have this present in my master node, because at the moment I have used my master node for submitting the job. What that would do is there are schedules which even clone the GitHub repo, select that file, and then run that file, and then delete off that repo from the local. It's the delete of that local copy of the repo. So it could go that advanced. And yes, that is how it happens in production scenarios. I think given the time, I'll take this last question.
Yeah.
Two scripts which you have implemented will be there once we log out from that particular Hadoop VM. Yes. So now what would be the life cycle of this particular two scripts? This would be present as long as my Hadoop or my Spark cluster is alive. So I can do that. So I'll just show you quickly. I think anyways, that went out, that session now became stale. I don't have access to it. So I'll come back. I logged in again, and here are the two files. So as long as my Spark cluster or my EMR cluster is up, I would have access to these two files. Later on, they will go away. If my Spark cluster goes down, they would be gone. So the better option is to just put it on GitHub and have that persisted. Okay.
Okay, so I will take over from here now, Shruti. That was it for the question and answer session, everyone. Thank you so much for coming today with us. I am posting on this chat now a Google form, which I'll request you to fill in so that, we can activate the free project for you. So this is one such project that Shruti showed us today that is there on Project Pro. We have 255 such projects. Along with and each of these projects, they come with data set, code, video, just like Shruti showed. Along with this, we also give one-on-one mentorship sessions, which is unlimited. Shruti also is a mentor with Project Pro. She takes questions related to career, technical interview preparation and anything related to project where you are stuck. So if you want to get access to this particular project, please feel free to enter in your details on this Google form. If you have any more questions, you can book a slot with one of my colleagues and we'll be happy to take your questions. After the session is over, allow us some time to send you the recorded version of this webinar that was hosted by Shruti. And any more last question that you have for me, I can take that up, else we will end this session. And I'm sure on behalf of everyone else, I'll thank you, Shruti, for devoting time with us today and for conducting this awesome webinar.
Thanks, Pragya. Thanks for giving me this opportunity.
Thank you.
Okay, guys, I have posted the Google form for everyone's perusal. Please enter in your details and we will activate the free project for you. It will take us some time to do that, roughly 15 to 20 hours. But we'll definitely do this and we'll get back to you. If you have any questions, please book a slot here, or you can also email me in case there is any delay from our end on this particular email address. Thank you so much, everyone, for joining in today. Hope you had a productive session.
Project Pro, the only solution for solved industrial grade projects.